used to connect several ECUs. CAN is used to communicate between ECUs without a host computer. It follows serial asynchronous communication protocol. CAN is a asynchronous communication protocol where one byte of only one way of communication can be happen. It is a off duplex protocol, and the CAN defined using OSI model. So the international standard organization ISO has further defined CAN uses the ISO model. So like the application, presentation, section transport, network, and data link, physical layer. These are the 7 layers. So here, like the data link layer, the L6 and L7. L7 is the physical layer. It will be operated. CAN bus is defined only between those 2 layers, where the signals, the physical layer moves the signals between the devices in the network. And on the physical layer, the CAN consists of 2 dedicated wires for communication. Data link layer provides the communication address and convert data frame into the signal and load them to the connected media. So that's how the data will be transferred between one node to the another node of ECU. How this OSI defines the CAN protocol? So generally, the OSI that defines is we have the physical layer and data link layer. In the data link layer, we have a LLC and MAC. So what it have is internally the LLC have the acceptance filtering, overload notification, or recovery management that can be happen, logic link control, and MAC will be the medium access control. So it have the data encapsulation, decapsulation, frame coding, and the medium access management, error detection, error signaling, acknowledgement, serialization, deserialization that can be happen in the MAC. So these are the 2 important layers in the CAN area protocol, where the data link layer is taking the more response on the LLC and MAC. What are the principles of the CAN protocol? So mainly the CAN follows wired and logic. The wires are called CAN high and CAN low. Wire and logic means 0 means dominant, 1 means recessive. 0 dominant is that whenever there is a conflict in the 2 data transmission, then the sender who is sending 0 will get the priority. What are the uses of CAN? It is more reliable and economic. Wiring is less complex and easy to implement the changes, and it is easy to integrate the additional control ECUs, and due to the simple wiring and failures can be easily diagnosed and that can be identified. What are the features of the CAN? So simple and flexible in configuration and prioritization of the CAN, and guarantee of latency time, and configuration is flexible, and message CAN, it is a message based protocol. It is a multi-master communication, and error detection and fault confinement feature is easy, and retransmission of the corrupted message automatically when the bus is idle, and system-wide data consistency, and distinction between temporary error and permanent failure, and autonomous switching of the defect nodes. What are the applications of CAN? Passenger vehicle, trucks, buses, gasoline vehicles, and many more. All automotive vehicles are operated with the CAN protocol, and it is a electronic equipment for aviation and navigation, and industrial automation and mechanical control, and aviators and escalators, and building of the automation, and medical instruments and equipment. What are the importance of CAN protocol? So it is a system flexibility. Nodes can be added and removed to the CAN network without any changes in the software or hardware. Message routing consists of the message is named by the identifier. The identifier describes the meaning of the data so that all the nodes are able to think if the message sent, kept, or discarded. Multicast, any number of the nodes can receive and act upon it simultaneously. And data consistency, a transmitter message is accepted either by all the nodes or by the node within the CAN network. The data consistency is achieved. Why CAN protocol is called a message-oriented protocol? So unlike other protocols, it is a completely the ID-based protocol, so not the address-based. And moreover, the message-oriented protocol means here the messages are not transmitted from one node to another node with help of address. So it based upon the identifier priority of the message that will be chosen will be transferred. the transmitting messages gets transmitted successful without streaming of the data. What is the standard CAN and extended CAN? So number of identifiers can be accumulated by the standard CAN as 2 power of 11, and number of identifiers for extended CAN will be 2 power of 29. Identify here, the standard will be having a ID of 0, and extended frame, it will be having a ID of 1. What is called a CAN terminal? CAN transmission plays a vital role and ensure that there is no data loss during the transmission. And CAN at the terminals, we are configuring with 120 ohms resistor at end of the transmission lines to ensure that data is receiving and transmitting efficiently. To minimize the reflections and to reduce the noise, we are using the 120 ohms between the two terminals. What are the three CAN layers? So mainly the objective layer, transfer layer, and data layer, and the physical layer. Speed and wake up mode in the CAN. To reduce the system's power consumption of the CAN device is sent to sleep by disconnecting the bus drivers. Wake up is done by any bus activity or by any internal condition of the system. What is the speed of CAN? The maximum speed of the CAN is 1 Mbps, and high speed is CAN won't work if there is a problem in the wiring, and low speed can work on asynchronous network as it's terminated growth at every node. That's why low speed CAN is called as a the fault tolerance CAN. Why CAN is a asynchronous communication? Data transmission is not synced with any external clock signal. Data is transmitted intermittently without dependency. CAN bus logic. CAN follows wired and logic. So here we have a CAN high and CAN low, where the data will be transferred with based on the dominant and the recessive mechanism. CAN consists of two dedicated wires on the physical layer, CAN high and CAN low, where the data will be transmitted. The CAN high goes 3.75 and CAN low drops to 1.25. When the bus is in ideal, there is no data transmission is happening. That time it will be the CAN high and CAN low will operate at 2.5 volts, and so that the CAN bus is not sensitive to inductivate the spikes or electric fields or other noise. When the CAN bus is in ideal mode, both of the lines carries 2.5. What are the bus values? The bus has got a logical value of dominant and recessive. Since CAN follows wired and logic, during the simultaneous transmission of the dominant or recessive bit, the resulting bus value will be dominant. A dominant bit is a logical Jew and recessive bit is a logical one. What are the types of frames in the CAN? So we have a remote data frame, error frame, overload frame, and interframe space. So here we have the two types of CAN, like the versions CAN 2.0a, CAN 2.0b. And how does the CAN standard frame define? So here we have SOF, startup frame, and 29-bit identifier, and 1 bit will be the RTF. So here it will be the extended CAN frame, where the standard frame it will be the 11-bit identifier. What are the fields in the CAN standard startup frame? Arbitration field 11-bit identifier, control field IDE or data field 0 to 8 bytes of data, CRC field 15 bits and delimiter, acknowledgement 1 bit delimiter and acknowledgement slot, and end of frame 7-bit recessive, and frame space 7-bit recessive. Standard remote frame in CAN and error frame in the CAN. So it will be a 0 to 12 superposition flags and 8 recessive delimiters. So error frame, we have a CAN message, error flag of primary and secondary error block, and we have the error delimiter. And we have the overload frame in the CAN. So here we have overload flag will be the 6 bits. It will be stuff, and we have the other overload delimiter. It will be having 8 bits. What is a CAN arbitration? So here the node which try to take control on the bus through the process is called arbitration. So let's consider the node A and B. They start transmitting the message. The node which have the lower identifier will get transmitted first based upon the identifier, and others should wait. And what are the active and passive and bus off states? So if any nodes transmits and receive continuously the fault error, so it will be disconnected from the network. There is some limit. So once the limit reaches, then it will be disconnected, and we have some part of recovered mechanism that will be followed. So for checking of the transmitting and receiving end, we have transmitter error counter, receiver error counter. So that keeps the track of error generated. There are three error states, like the active error state and passive error state and bus off state. What is a CAN bus off? So it is a CAN node enters the bus off state when the T counter is more than 255. In this state, CAN node will be removed from the CAN network, and now it will be no longer available on the CAN network to participate in any CAN activity. Modes to achieve the CAN bus off. So here, CAN high interrupt, CAN low interrupt, or CAN high short to battery voltage, CAN low short to ground, CAN high short to ground, CAN low short to battery voltage, CAN L short to CAN high, and CAN high short to CAN L, interrupt at the some location, and there will be loss of the connection in the terminal network. Why 120 ohms will be because that between the two lines there will be noise will be added, and the data correction or data interrupt can be created. So to avoid that, the electrical statistics between the two wires, so here we are configuring 120 ohms at each end of the CAN high and CAN low to ensure that data will be transferred efficiently. How we are recovering of the 120 ohms? So identify the causes. So before attempting the recovery, we need to essentially identify and address the root cause of the burst of condition, and wait for automatic recovery. And manually, we need to reinitiate the recovery. So by putting the CAN control in the restart, and wait for the period and release from the reset and reconfiguring the restart. And we need to verify the communication too. And the other part is we need to address the underlying issues. So these are the some stages where we need to recover the bus of error, and we need to ensure that 120 ohms is efficiently communicating between the devices. What are the 5 types of errors in the CAN? There are 5 types of errors in CAN. There are acknowledgement error, bit error, stuff error, and form error, and CRC error. What is a bit stuffing? When 5 consecutive bits of the same level is transmitted by the node, it will be add a 6 bit of the opposite level to undergoing bit. The receiver will be remove this extra bit. If more than 5 consecutive bits of the same level occurs, but a stuff error is signal. Example, like if the positive, so here we see there are 5 zeros and followed by the 1. So instead of the 1, we have the 6 zeros. It will be a bit stuffing error. It should not be happen. That will be, and the negative transmission, these 6 bits or zeros are the same, or ones or the zeros. It means that will be a part of a stuff error. What is the CRC error? Transmitting nodes calculates the 15-bit cycle redundancy checksum. So CRC depends upon the message carried by the data field. So the receiver node will also generate a 15-bit CRC checksum. Then it compared with the receiver one. So if both varies, the CRC error is flagged. What happens if I have to send more than 8 bytes of it? So mostly we need to use the transport protocol. So that will be a part of a flow control mechanism where the data will be transferred. So one for the broadcasting the data, other for sending the specific address. These are the 2 types of CAN-TPs that should be followed. What is the delimiter? So in the simple term, so the delimiter is a sequence of 1 or more characters for specifying the boundary between them that we are separating, or we are independent the reasons in the plain text or other data stream. So delimiter represents one of the various means to specify the boundary in the data stream. So in brief, when a program stores sequence or tabular data, it delimits. indicates that beginning and ending of the specific statement each item of data within a predefined character. Performing of the error detection mechanism has the following properties. All the global errors are detected. All local errors are at the transmitters are detected. Up to 5 randomly transmitted errors in the messages are detected. Errors of any odd numbers can be detected. What is a CSMA CA and what is CSMA CD in the CAN communication? CSMA CA is a carrier sense multiple access collision avoidance. If the bus is ideal, then it will be start transmission. Otherwise, it will wait for the bus to be ideal. CSMA CD is a carrier sense multiple access collision detection, detects the collision and stops the further data transmission and initiate the data retransmission. CSMA CA is used to avoid the collision and data corruption. What is acceptance filtering? Acceptance filtering are used to filter the received CAN messages according to their ID. So the firmware is not interrupted by the messages. Filters are applied after the hardware receives the messages. The acceptance code or acceptance mask are used for filtering unnecessary CAN messages to RS-232 port. Acceptance code, the CAN ID bits that you use to get it. Accepting mask is the CAN ID bits that you want to filter. What is data encapsulation? Data encapsulation, also known as data handling. Each OSI layer asks for service from the next lower layer. The lower layer encapsulation the high layers data between the headers. The OSI model uses a different terms. The PDU, here we have the PDU is the protocol data unit. It represents a unit of data with headers and trailers of the particular layer as well as the encapsulation data. What is the error detection and signaling? Error handling aims at detecting error in the messaging appearing on the CAN bus so that the transmitter can retransmit or enormous messages. Every CAN controller along a bus will try to detect error within the message. If error is found, the discovering node will transmit error flag, but thus data in the bus traffic. The other node will detect the error by using error flag and discard. What is a bit encoding and decoding? Bit with a bit stuffing. Can users say return to 0 NRZ? We are encoding with the bit stuffing for data transmission on the differential to wires. The use of NRZ encoding ensures that compatible messages with a minimum number of transmission and high resolution to external disturbance. Non-return 0 means the binary signal to be transmitters are mapped directly, a logic 1 to the high level 0, a logic 0 to low level. Characteristics of NRZ coding is that consecutive bits of the same polarity exhibits no level changes. What is hard synchronization software? Hard synchronization is used to resynchronize the node with significant timing drifts involving a hard reset of the node's timer upon the detecting a dominant bit. Soft synchronization, on the other hand, adjusts the timing of the node more generally using minor adjustment to the realign with the network without a full reset, typically after detecting the edge of the dominant bit for the minor corrections. What is bit timing under synchronization? The purpose of bit timing synchronization to coordinate the oscillator frequency in a CAN network and as a result provide a system-wide specified time reference. When any ECU tries to send a message at the time of the CAN bus is ideal, the data frame having a consists of SOF in a dominant bit. The high to low edge of the SOF is called as the high synchronization in the CAN protocol. What is nominal bit rate in the CAN? Nominal bit rate is the number of bits per second transmitted in absence of resynchronization by any ideal transmit. So nominal bit rate is, so it will be transferred 1 bit at a nominal bit. What is a bit rate? So bit rate is how many bytes of data that we are transferring per second. What is a baud rate? Baud rate is number of times the signals is communicated in the channel per second. CAN bit and sample rate and time calculation, how that can be validated. So here we have